What's up everybody, the Network Berg here. Hope you've been doing well. In this video we will be covering... Hang on. I just heard something really strange. I have no clue what that was. Anyways, back on topic. This is the Network Berg. Welcome to the stream. It's not a video. And in this stream we'll basically just be having fun in EVE-NG. We'll be setting up some different topologies. Well, we'll just be on one topology, but I'll be doing a bunch of different stuff, just like adding a ton of different routers and switches and maybe some firewalls or what have yous, and have a good time. Cool. So before I do anything, I just want to stop this lab that I'm currently running, and then we'll create a completely new lab from scratch. So I'm doing that now. All my nodes are shut down, so I can just close the lab. And let's create a new lab. And we can call this lab, let's call it Network Berg Stream Lab. Awesome. I'll leave it on version 1. I can make myself the author. And I'll just save it as is. I'm not going to add anything additional here. So let's take a look and see. We've got a new topology, and in this new topology I'm just going to add a couple of nodes. So I might just add some MikroTiks, since that's typically the device that I'm showcasing on the channel anyways. And how many nodes do we want to add? Well, it depends on what we want to do really. So I'm going to act as if I'm going to be building some ISP network from the ground up, and I'm just going to go haywire and imagine this is a very messy ISP. They've got a ton of different routers doing various different things, maybe some routers doing LTTP, other routers where they bring some IPsec in, you know, the usual. So let's maybe add a core network of, just to begin with, let's make it like 7 routers. I'm going to switch the version to 6.48 because I don't want to use the beta. And I'm just going to make it 12 Ethernet ports. And let's import all of these different routers. So now we've got a bunch of different routers. And I'm just going to throw them around the topology. Let's maybe do something like that. That looks pretty good. And now we just need to kind of connect these routers. So how do we want to connect them? Let's kind of make these 3 into a mesh. So let's do them ether 1 to ether 1. This is ether 2 to ether 1, but we can see the interfaces on the routers, on the links. And I might just add a single link between these 2 routers at the bottom. I might just add another single link between the routers at the top. I'm going to add more links to more routers, so that these devices can ideally communicate with each other. Cool. So this is just really to get the devices connected to each other right now. And I might make these 3 at the right also a little mesh. Let's maybe see on Pro. Let's do the auto align. So that looks a bit nicer already. And what I'm going to do is just switch the routers on so long. So I'm going to start selected, and this should bring all of the nodes up. And while they come up, let's just quickly add some text lines, because we want to figure out what type of IP addresses we want to configure between our links so that the routers can actually have IP communication. So I'm just going to make it maybe something in the 10 network, because I like typically using the 10 network for either in the ISP network, but you maybe want to try and use something more or less at the end of the 10 range, because a lot of customers also like to use stuff in the 10 range, but not so much. Mostly they play around the 192 and 172 ranges. So let's maybe make the link something like 10.255.0.0, and let's just start at a /30. And I'm just going to duplicate that, and then each link I'm basically going to give an IP for now, or a range. So I've got how many links? 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm going to need 9 IPs, or 9 ranges at least. 6, 7, 8, 9. All right, that looks trippy. So let's just quickly throw these IPs somewhere on the topology, and then we're going to start editing them as well. This is also for our own sanity. It's good for you to document beforehand where what is. Don't just start like throwing random IPs on the network, because you're going to forget where what is, and it's going to cause you some hassles further down the line. Alright, nice. So let's maybe just leave this first one here as is. The second one, if we want to make it like a lot quicker, we could potentially just do something like this. So make that .1, .2, .3. And this stream I might leave on for a bit longer, because this isn't like the previous stream where I'm just showing you how to install EVE-NG and whatnot. This is more or less us just working through networking concepts and setting stuff up together. So the stream might be longer, but please remember that you can rewind if you want to look at something again, and the video will be posted afterwards for you to go through again. So this won't just be lost in time. Okay, so that's .3. Let's make this .4. And this I'm just doing for the sake of being fast. We could subnet this maybe like a bunch of /30s, and it would go a lot quicker, like leave it in the 10.255.0.0, and then we move up from 4, 8, 12, etc. But I just want to do this for the sake of being quick. So here we can do .7, and then finally .8. Awesome. So now we know what IP ranges we want to allocate for the links between all our routers. Let's just decide which device is going to be what. So I might just duplicate this IP again. And let's just make, because this is going to be fairly straightforward now as well, because everything's just going to be .1 and .2. Let's make it .1 and .2. Let's make this router on the left .1, this one .2. Let me duplicate again. This one will be .1, and the one next to it will be .2. And again, this is just relaxing. We're just planning the network. We're not even configuring anything yet. These are all blank routers until we have the layout and we understand what we're doing. So duplicate some more. And I know this seems boring, but it is fun. It's relaxing actually. So .1, .2, .1, .2, and I'm going to do this for a bit longer. Let's just make that one .1. Next one .2. Duplicate. Let's keep this one as .1. Make the one at the bottom .2 again. If you guys have questions, you're more than welcome to ask. And .1. So we've got a bunch of .1s, .2s. Let's make that top one .1 again. Make the bottom one .2. Make another .1 at the top. And we're almost done with the basic layout. I'm not gonna rotate and make the stuff look super nice just yet. We'll do that later on probably. So we can make that .2. Let's make that one .2. And the last .1. So now we've kind of mapped out what IP addresses we have between our routers on our provider network. Pretty cool. So let's just start doing a base configuration. So I'm just going to first hop onto MikroTik 1. Apologies, I might do a lot of the setup on command line because I find it to be a bit quicker, but I will definitely do some stuff on Winbox as well. Don't worry about that. It's just adding like stuff like IPs and configuring some BGP stuff it's really fast on the command line. So let's add the IP's IP address, add, and then let's look at what IPs we had. We had 10.255.0, 6 and 8. Okay, so let's start with the .0 one. So 10.255, or we need to say address equals 10.255.0.1/30. And the first interface is Ether 3 actually. So let's put that on Ether 3. I can just upkey it, and let's see. Ether 2 is 10.255.6.1. Just confirm again, Ether 2, yes. So that is 6.1. And then we have Ether 1 running on 8.1. See, very basic, just IP addresses, nothing special yet. Very standard basic stuff. Let's also do something like adding names for our routers. So let's do a system identity set name, and let's make it R1. And I might just enable ROM-on from the beginning on all of the routers as well, just to make it easier if we do need to Winbox and later on. So tool, ROM-on, set enable, yes, and let's go. ROM-on is up and router 1 is having IPs on its links. Let's go on to, it's funny, I might power these things off and just, hang on, I'm actually going to do that just for my own sanity. So let's stop them. And I should have actually added these nodes as this. So this will be R1. Because I could have made the prefix that, and then it would have added R1, R2, etc. But now it's MikroTik 1, 2. But I just want to do this manually so we all get a good visualization of where which router is as well. So let's maybe make this one R4. You, my friend, will be R5. Let's make you R6. And then we get R7 coming. Perfect. Okay, so we've got all our routers identified now. Let's just start the devices up again. And this should be quick. There we go. Okay, so let's jump onto R1 or R2, sorry. And then from R2, we're also just going to quickly assign the IP addresses. So we're only working with Ether 1 and 2 at this time, so I might just do this admin blank. So if I scroll up, no. So let's just do that system identity set name R2 tool ROM-on set enable, yes. And let's add our IPs. IP address 10.255. Oh, I always forget that on MikroTik. 10.255.0.2/30. And this should be on the Ether1. Yes. And then on Ether2, we've configured it, or we've planned it as 10.255.1.1. Awesome. So from router 2, let's just see, can we actually ping, what am I pinging? 10.255.0.1. So I can ping router 1 from router 2. Great. Now let's jump onto router 3. And it's going to be pretty much the same process for all of the routers until we've assigned IP addresses everywhere. So admin blank system identity set name R3 tool Ramon set enabled yes, IP address add. So then the addresses will be 10.255.1.2 10.255.1.2/30, and that is on Ether1. For Ether2, we're using 10.255.2.1. And then on Ether3, I have 10.255.4.1. Excellent. Now let's jump to the other routers. So let's go to router 4. I'll just do them in this order. Admin blank, no. So system name, system identity set name R4, tool Ramon set enable yes. Let's add our IPs, IP address, add address equals, and let's see. So this is Ether1 is 10.255.7.2, 255.7.2/30, and that's Ether1. On Ether2, I have the address of 10.255.6.2, and on Ether3, I have the address of 5.1. Awesome. Let's jump onto R5. And then from R5, we do the same deal. Admin blank, system identity set name equals R5, tool Ramon set enable yes, IP address add address equals. So here we're using on Ether1 10.255.5.2/30, and that's on Ether1. Let's just confirm. Correct. Let's add our address onto Ether2. So this will be 10.255.3.2. And then lastly, the Ether3. That address is 10.255.4.2. Yes. Okay. So all of those IPs are added. So now we just need to do routers 6 and 7 quickly. And they'll be super fast since it's just the two routers. So let's admin blank. Let's do a system identity set name. This is R6. Tool Ramon set enable yes. IP address add address. Addresses for router 6 is 10.255.8.2/30 on Ether1. Well, you could use this topology for anything really. Just think of this as a very base ISP network where we might run some various services. Just think of this as the core network that we're busy sculpting and building. So from this network, we might deliver certain services where we might bring routers behind our edges. So like router 7 and 6 might be an edge, and we could bring in customer links onto those routers, and we could provide internet to the customers. We could provide other services such as the VPLS, MPLS, many different things. And I just want to focus on building that network so that we can start doing those things. So we've got our IP address, add 10.255.8.2/30 on Ether 1. And on Ether 2, it's 7.1. Another cool thing, which I haven't made any videos about, but you could potentially do this on a network like this as well, is traffic engineering. So, pretty cool. Ether 2. Now let's just do the IP addressing for the last network. Admin blank, no. System identity set name, R7. Tool, Ramon, set enabled, yes. IP address, add address. And then our addresses will be 10.255.2.2 on Ether 1. Interface Ether 1. And then lastly, we have 10.255.3.1. Awesome. So now all our routers have IP addresses, and they can directly communicate over IP to the routers they are connected with, which is a good step, but it leaves a lot to be desired, because if I'm sitting at R6, the only stuff that I can ping is router 1 and router 4. So we can quickly test that and make sure. We could probably, we'd first have to do the ping. So let's see, IP address print. So let's ping 10.255.8.1. And let's ping 7.2, which are my direct links to router 1 and 4. But besides those links, I don't have any other way to get to anything else. I can't get to the IPs configured on router 7, for example. I also can't get to router 5, router 3, or router 2. So I'm limited to only being able to access the stuff that I'm directly connected with. If I look at my IP neighbors, I can also see more detail, like what the IPs are of the MikroTiks that I'm connecting to. One more thing I want to do with the addressing, and this is also actually quite important when you're planning maybe is it okay to assign a VLAN ID on a bridge or interface? So yes, it depends what you're wanting to do with that VLAN. So we're going to be doing some stuff with VLANs a little bit later on. This is just now for our core network. So I'm just quickly going to add some more text quickly, because what I want people to, well, not people, but anybody really, is when you're building these networks and you are thinking about delivering certain services in the future, consider assigning what we call a loopback address on your provider network. So each router would have its own unique loopback address, and you'd use those loopback addresses for the routers to communicate with each other. So even though the link goes off, so if the link between router 1 and 6 would go off, this 10.255.8.0/30, it becomes unreachable, but there would be different ways in the network to get to router 6 still, and that's why we'd use that loopback address. So let me just add some loopback addresses. I'll just use stuff in the 9.9.9. Let's just make .1 will be the first address, so that will be router 1's loopback address. I might just make this a bit bold and change the color actually. So maybe like a nice deep red. And that will be the loopback address for router 1. I'm going to assign a loopback address of .2 for router 2. I'm going to assign a loopback address of .3 for router 3. And I'm pretty sure you all can see the trend that we're kind of going into. Each router will just have dot whatever it is. So router 4 will be .4. And we'll use these loopback addresses as the router IDs as well for stuff like our OSPF and our BGP. So we're duplicating this quickly. Router 7 will be .7. And then router 6 will be .6. So each router now has its own unique loopback address. So let's just assign those loopback addresses. And the loopback address you would ideally just assign directly on a bridge interface. So you won't assign any ports to the bridge. You'll just leave it a blank interface, but you'll assign the loopback address to the bridge. So what we're going to do is just interface bridge add. We can make the name L00, and then we can add the IP address 9.9.9.1 on the interface L00. And I'm just going to copy this command actually, because I'm going to paste this onto any of the other routers quickly. And this is where something like Ansible would be very useful. So we could just quickly orchestrate and send out this config in mass to all of our routers. So let's just do an IP address add UR address 9.9.9.2 on the interface LO. For router 3, we're adding the loopback address, and then we're doing our IP address add address 9.9.9.3 on our loopback. Let's go to our router 4. Paste, assign the IP address 9.9.9.4 on allo. Let's do this on router 5. Add our bridge, add our IP address, and our address is 9.9.9.5 on our loopback. Jump onto router 6. Let's quickly add the bridge, add the IP 9.9.9.6 on allo. And now our last router. So bridge added, IP address add address 9.9.9.7 on our loopback interface. Awesome. So now we've got loopback addresses assigned on bridge interfaces on all of these MikroTik routers. And I would like us to just now build something so that we can reach our core network across everything. So I just want to demonstrate. Let's go back onto R6. And I want to prove, okay, if we look at our IP routing table, we don't have any routes except our directly connected routes. And there is no way for me to get to like the IP addresses at router 7. So if I do a ping to 255.2.2, it's not going to go anywhere. 10.255.2.2. It's unroutable at the moment. And if I try and ping that loopback address 9.9.9.7, and this is also a nice thing about the loopback addresses, this is way easier to remember than all of your link addresses between all of your routers. So for this, we probably want to run a routing protocol to learn about all of these routes throughout our network. And there's only one feasible routing protocol that I can think of when running on MikroTik. You could argue you could use the other things like RIP or the MME or whatever, but the thing you're going to be using is OSPF. It's just kind of how it is. MikroTik has OSPF. It works for it. It's kind of what it's designed for in your internal network. So we're just going to build a backbone OSPF for our our network, our mpls almost. So I'm going to jump onto router 1, and there's going to be very few changes I make, and this is just going to allow my whole network to learn about all of my routes, all of my interfaces and stuff. So we're just going to go into our routing, and if you go into routing OSPF, if you do an export, it's blank, but if you do a print or instance, and we look at a print there, you can see there is actually something already there. This is your default OSPF configured, and we can use this actually just for the beginning. We can build our backbone off of this. So what we could essentially do is routing OSPF instance. I might set, and I'll change the router ID because this needs to be unique on each of your routers participating in the OSPF. So this is why I've assigned this loopback address. So I'm going to use 9.9.9.1 because I know it's already unique on my network. I am going to also just redistribute some stuff. I'm going to redistribute my connected routes as type 1, and I'm going to hit enter. It is going to be 0 because that is the first thing. And I also just want to, even though you don't really need to, but just to be safe, I'm going to go into my routing OSPF network, and I'm just going to add, actually let's not worry about that yet. we'll do that later if it's needed. Let's just set up the OSPF quickly. Oh, we actually do need to do one thing. So in our routing OSPF networks, we need to add our link networks so that we can dynamically pick up which interfaces are running OSPF. Because if you go routing OSPF interfaces and you print this, this is going to be blank. But what we want to do is we want to add a network, and our network, this will now be our addresses or our networks between our links. So we're on router 1. So there are 3 networks we want to add, namely .8, .6, and .0. So let's add them. 10.255.0.0/30, and our area will be the backbone. This is on by default. You're not adding the backbone. It is configured by the MikroTik when you start it up the first time. Okay, I said .6 and .8, so let's just add those areas or those networks to the area as well. And if I print the interfaces again, you'll actually notice it's created these dynamic interfaces for the OSPF. It's starting to broadcast traffic because it's wanting to find OSPF neighbors. It wants to form relationships and say, hey guys, let's exchange some routing information. Let's learn some stuff. So I'm going to do a very similar thing on all of the other routers on the network quickly. So let's jump on router 2. And then for router 2, all we're doing is routing OSPF instance set. And we can set the router ID to 9.9.9.2. And I can just redistribute my connected as type 1. So what redistribute connected means is any of my directly connected routes on the router, in that routing table, I'm going to redistribute to my OSPF neighbors. So this will then send out my loopback address to all of my neighbors, even though I've specified the link addresses between all the devices as well. So let's just add these link addresses to the networks as well. routing OSPF, network add, and then we just want to add our networks. So this is very simple. This is .0 and .1. So 10.255.0 in the area backbone, and .1. And if I do a print of my OSPF interfaces, you'll see these two interfaces are now participating in OSPF. They will try and form neighbors. And in theory, I should already have a neighbor. So if I go routing OSPF neighbors and I print, I have one neighbor, and this is with router 1. The state is full. I wonder, can we do this? No. So if I do an IP route print on router 2 now, cool thing is I am learning the loopback address of router 1, and I'm also learning about the link addresses behind router 1. So these are the addresses that are going to router 6 and 4. Okay, so let's just continue with the OSPF setup and configure this on all of the other routers. So router 3, we're going to go into our routing OSPF instance set. We're setting the router ID for router 3 as 9.9.9.3, and we are redistributing our connected as type 1. And we're adding the networks now. So routing OSPF network, add network equals. So let's just see, router 3 has .1, 4, and 2. So 10.255.1. And then we can go into the area backbone. So I said 1, 4, and 2. Okay, so router 1, 2, and 3, all three of them are now configured with OSPF, and they should actually learn each other's routes currently. As soon as the neighborship is formed on router 3, we should be learning some routes, and there we are. So we're learning router 1's routing, and we're learning the routes behind router 2 as well. So our routing table is expanding quite rapidly now. Let's jump onto the other routers and just finish the setup for the OSPF, because it is kind of mandatory to have a protocol like OSPF running on the back end of your network, which is an IGP, just to distribute the routing information throughout your network. All right, routing OSPF instance. We're going to set the instance. We're setting our router ID to 9.9.9.4, and we are redistributing unconnected as type 1. And let's add our network, routing OSPF networks, add. Our network is 6, 7, and 5, or we can say 5, 6, 7, easier to remember. So 10.255.50 in the area backbone, 5, 6, and 7. So if we do a routing OSPF neighbor and we print not network neighbor, you can see it has formed some adjacency. That's the nice word, and it is, or it has formed that with router 1. And if I look at the routing table, I'm learning routes for router 3. So router 2, 3, and 1, I'm learning the routes. Awesome. Let's jump to router 5, do the same thing. So routing OSPF instance set, router ID 9995, redistribute connected, yes, or as type 1, sorry, this is what you do on OSPF. Routing OSPF network, adding a network, and our networks for router 5 is 4, 5. So 3, 4, 5. Very easy to remember as well. 10, 2, 5, 5, 3, 0/30. And our area is the backbone. So 3, 4, and 5. Okay. I'm just going to close that because I'm very confident it's working. So let's go to router 6. Routing OSPF instance set. And we're setting our router ID to 9.9.9.6. And we are redistributing our connected as type 1. And we're doing routing OSPF network add, and our networks are 7 and 8. So 10, 2, 5, 5, 7. Greetings, Pritesh. And the area is the backbone. And now we're going to go to our last router, which is router 7, just to finish the OSPF setup. So we're going to do something like routing OSPF instance set the router ID, which is 9.9.9.7, and we're redistributing our connected as type 1, and we're doing the routing OSPF network add, and our networks will be .2 and 3. Okay, so 10, 2, 5, 5, 2, 0, area, backbone. Sorry about that, there's like a fly flying around here, pretty annoying. Let's see. Okay, so we've configured the OSPF, and I'm just going to go back to router 6 where we started from. And if I do an IP route print, I should be learning a lot more routes than when we initially started. So I'm learning the loopback addresses of router 1, 2, 3, 4, 5. 6 is the local address, and then .7. So I'm learning about all of my routers via the OSPF. And if I do something like a ping to 9.9.9.7, which is router 7, so I'm pinging across the whole network, I'm able to get to router 7. If I do the trace route to it, let's just see what path it's taking. I'm pretty sure it's very complex path, since all of the links are basically the same bandwidth, same speed, same distances. So good luck to this route. So it's actually going to 7.2, which is router 4. And then from there, it should be going to 5.2, which is router 5. So it's actually just following this straight path. Actually, I was wrong because I forgot I didn't add a router here in the middle. So it's not an even path. This is why it's taking this bottom path now, as opposed to the top path, which has one additional hop there. Okay, so we've got a little bit of an OSPF network. So this is really the building blocks of any type of network that you want to be running. Things that people typically, I'm not saying you should enable this. If you don't have a requirement for it, don't. But MPLS is something very strong to run on your provider network, seeing as it allows you to provide services such as the layer 3 VPN, which is actual MPLS, and VPLS. So you would need something like MPLS running on top of your router in order to do MPLS, VPLS, and traffic engineering correctly. That's just how it is with MikroTik. You could have different routing tables and you could be importing the stuff, but that's way too much manual overhead. So as a basis for this network we're building here, we're going to enable MPLS from the get-go as well. So similar process on router 1. We're just going to jump on. And to enable MPLS is actually very straightforward. So we just go into our MPLS LDP, because we use LDP for MPLS. We're going to set it as enabled. And here's another reason you want those loopback addresses. We're going to use an LSR ID, which will be the loopback address 9.9.9.1, and we're going to set the transport address as the same. So the loopback address, which the OSPF is like sending out throughout the entire network, is what we're using so that the MPLS will always stay up. Very interesting. So I'm just going to add this. And then the next important bit is just to MPLS LDP, and then we need to set our interfaces. It's very straightforward for our network because we already know what our interfaces are. So for router 1, it's Ether 1, 2, and 3. So let's just quickly add them. Interface add. So this is Ether 1, Ether 2, Ether 3. And what I want you to note before I add anything else, if I do an MPLS remote bindings and I print this, it's blank. So I'm not sure how familiar many of my viewers are with MPLS, but it's basically a protocol that exists between layer 2 and 3. Think of it as a way for your routers to look at the routing table and almost act as if it was switching the traffic. So it would have a table of all of the IP ranges, and those IP ranges would be in a switching table almost. And instead of being MAC addresses being switched, it's the IPs that's being switched. So instead of your router having to do this whole route lookup process and look at everything, the MPLS is just switching the traffic, which is really cool. But that's a really dumbed down explanation of it. If you do research on MPLS, there's books about this stuff, man. It's amazing. All right, so let's just enable the MPLS on the whole network so that we can actually provide proper services to our customers in the future. So we're just doing very basic MPLS LDP set enabled yes. Transport address will be the loopback address. Our LSR will be the loopback address. We're doing MPLS LDP interface add. And for router 2, it's just Ether 1 and 2. So interface is Ether 1 and Ether 2. So I just want to jump back onto router 1 quickly. I don't know if I still have it open here. I don't, so let's just open it up again. And I want to have a look at those remote bindings from before. So if I do an MPLS remote bindings print, we're actually seeing the routes that is being learned through the MPLS, and the MPLS is telling you how it's going to get there, what the labels are, if the labels are being popped and all that stuff. So this is actually pretty interesting. Now let's do the same on router 3, and then we'll have a look at the table again for router 1. So router 3 I've still got open here, so let's just do MPLS LDP set enabled yes, LSR ID 9.9.9.3, and our transport address is 9.9.9.3. We're doing the MPLS LDP interfaces add, and for router 3 it is Ether 1, 2, and 3. So interface is Ether 1, 2, and 3. Okay, so let's jump back onto router 1. You see we had 15 entries here. So if I look at my bindings now, I still only have the 15 entries, but I kind of know why. Because everything is still on that specific peer. Okay, so let's just quickly add some more stuff on routers 7, 5, 4, and 6. So let's just go to 4, add from there quickly. So we're doing the MPLS LDP set enabled yes. Our LSR is 9994 and our transport is 9994. So router 4 also has the 3 interfaces, so MPLS LDP interface add. The interface is Ether 1, Ether 2, Ether 3. And if I actually go to router 1 now, you'll see we're going to be learning a lot more stuff, way more stuff. So now we know how to get to things through router 2 and router 4 on the MPLS. So let's do the same for router 5 quickly. You see, it's a bit of like repetition, but this is just for the core network now. When we start adding some more services, you'll see why we've done this base building. So MPLS LDP set enabled, yes. Transport address is 9995 and our LSR is 9995. MPLS LDP interface add. Our interfaces for router 5 is also 1, 2, 3. Ether 1, 2, and 3. And let's do the MPLS on router 6 quickly. Still running that trace route, cool. So MPLS LDP set enabled, yes. Transport address 9996. Remote address, or not remote address, what am I doing? LSR 9996. MPLS LDP interface add. Our interfaces should be 1 and 2. It is. Ether 1 and Ether 2. And then lastly, now we're going to go to router 7. We're going into our MPLS LDP set enabled, yes. Router LSR ID is 9997, and the transport is also that loopback address. And then we're going to go into our MPLS LDP interfaces, add. Interface should also just be Ether 1 and 2. It is. Ether 1, Ether 2. And that does it for the MPLS. So if I go back to router 1, and if I look at my bindings, I'm learning quite a few routes. And this is now in the MPLS table. And this is through router 6, router 4, and router 2. So I'm learning how to get to these things through the label switching. Let's just go to router 2, since that's nice and in the middle somewhere, but it should only show these two peers. MPLS remote bindings print. So you see there's substantially less information, but it's only peering with the two routers. Okay. Now we have MPLS and IP connectivity throughout our entire core network. So let's just make sure it's still working. 9997, and it does. I'm just quickly going to switch over to Winbox just to verify a few things. So I'm just going to add a network, add my management network, and I'll just connect onto router 2 quickly. Remember, I did add ROM on all of these routers, so I can get to any of them from Winbox on my actual computer through my neighbors. If I connect to the ROM on, there's just something I want to check on router 3 quickly. So I can see router 3 is on the list, and I will connect to it. So let's look at what's happening at router 3. Router 3 is, I just want to check the MPLS, make sure all of this stuff is good. That's fine. Okay, so our settings are all there. Awesome. So now we have a very basic core network. We could name these interfaces as well, but for the sake of interest, I'm not going to do that, not right now. So let's do something a bit more fun. Let's maybe bring in another node, and this node is just going to be a little Cisco switch. And the reason I want to use the switch is, let's add 2 nodes actually. Let's call this a switch. So you could call this an access switch, and this would maybe be where if you're handing off to a, or if you're getting layer 2 services from some fiber provider, they might bring in an interconnect into the switch, and then from the switch they might hand some VLANs off to you, and these VLANs you'll bring into your network, and then you'd be able to get to the site. So let's just quickly emulate that and act like we're bringing up a customer site through fiber or wireless or microwave or whatever for the first time. But first we want to add our access switches. So I'm adding this router. Oh, well, not router, it's a switch. Let's just find a nice switch image. I might use one of my imported or custom images. Where is a nice switch? Come on. DSLAM, I haven't seen a DSLAM in a while. They're actually decommissioning DSL in my country, in South Africa. They're getting rid of it because it's old, and a lot of the times the copper gets taken out of the ground. So it's all about the fiber and the wireless connectivity right now. You know what, I'm just going to use one of the base images. There should have been a switch here somewhere. Server. It's not really a layer 3 switch, but let's act as if it's just something for layer 3. So this would just be a switch where our upstream or our other service provider is going to be giving us a cable with a VLAN so that we could bring a customer into our network. So I'm just going to add another node for a customer. This might be another MikroTik router that I'm putting down at the customer. I'm going to call this a CPE. I'll add 2 of these, and let's maybe make it 12 ports as well. So the CPEs, I'll probably just get one side connected so long. So the CPE, let's just say it's going to this other service provider's switch or whatever, and then it finally gets to our access switch. So on the router, I'll connect Ether 1 to E00 on the switch. And then from the switch, I'll bring this into my actual network. So this router 6 is actually what we would call a provider edge now, because it is the border between our provider network and our customer networks. So this I could bring into Ether 3, that's fine. So now we have this little access switch with a CPE here, and I'm just going to start up the CPE. So typically if you order a layer 2 service through a vendor, yeah, no, that's an actual thing. That's the polite way of saying it, the taken out of the ground. It's actually a bit more chaotic what happens. Alright, so we've got our switch, and what we're going to do with the switch is just enable. I don't often work on Cisco, but the concepts are relatively the same for any vendor. So let's just do a show VLANs. I know already Cisco has these reserved VLANs, and then they've got VLAN 1. So this is our access switch, and you can assume that this cable running from the CPE, in between there might be a cloud running through this other layer 2 provider's switches and their own network, but they're finally just handing it off to us on our switch in our data center. So what they would do is typically give us a VLAN. So let's assign some random VLAN. Let's maybe make it like 1030. So that's what we're gonna use. So let's go config T. Let's do a VLAN 1030. We can give this a description, or we can give it a name, and this name would be CPE 10. Let's just call it that. And then what we could do is we could look at our ports that's running to our environment. So I know that Ether 1 goes into my router in my data center. So for Ether 1, I could essentially now do something like, we could even make it a trunk, to be honest. we should make it a trunk. So before we do anything like that, let's just do a config t interface E01 switchboard mode trunk. I think it's going to complain to me. Yes, it's complaining at me. So let's just go back up, switchboard trunk encapsulation, and we're going to do this as .1q because it's a VLAN. And now I can set the mode as trunk. And now if I look at my trunk, so this is now just a trunk port running from the switch to my MikroTik, and now I can span whatever VLANs I want across the port. So what I do want to do though is this port going to E00. What I could do is, if you apply for a link from a layer 2 provider, they might ask you one of two questions. Do you want the service tagged or untagged? So untagged would essentially mean on their equipment, when they hand off the VLAN to your CPE, it's untagged, so you don't need to do any tagging on the CPE. Or you can tell them you want the services tagged, and then the VLAN is tagged all the way through. So let's just assume the VLAN's tagged all the way through. So, but on that service provider's like we would probably be running a trunk to them as well, and we'd add the VLANs on that. But I'm just going to, for this example, add this VLAN 1030 as a direct VLAN on there. So we're gonna go into our interface E00. We're going to do the switchport mode as access, and then switchport access VLAN. Let's just make that, because now we're actually going to untag it, sorry. So we're going to untag this as VLAN 1030 for the CPE. And let's just write this. So if I do a show VLAN, I can see my 1030, which is for CPE 10. It's currently, well, tagged for ET 0/0. And for router 6, what I actually want to do is, let's do it from Winbox, because I think some people actually want to see it that way. So let's just Winbox onto router 6 quickly. Connect to ROM on. We've got router 6, connect. Go into our interfaces, and we know Ether 3 is going to our access switch. So what I could do essentially is go into interfaces. I can add a VLAN, or I can just go to the VLAN tab, add the VLAN. Let's call this CPE 10, or we could call it cust1 CPE 10 or something. What I tend to do is probably make it like ISP underscore customer underscore maybe like a service tag if they give you a service tag. So it might be something like the line number that you have with them, and then the size of the link. That's typically how I like to name my links, but it might vary for some people. You might do something like, you might make it the VLAN at the beginning and then call it CPE 10 and then do something like 20 meg or whatever. One downside with using the MikroTik routers in Eve, everything works, all of the functions, it's just, it's very limited. So all of these links can only operate at 1 meg, unfortunately. All right, but we are going to assign the VLAN 1030 now to Ether 3, and we are going to apply that. So we've got the 1030 there. If I go into my IP neighbors, I wonder, will I see anything yet? I am actually seeing something. Ooh, and it's the, I didn't change the base version for the CPE, so they're actually running 7.1 now. But isn't that cool? I can see the CPE 10 now as a neighbor through my fiber provider or wireless provider's network. And let's just quickly assign some IPs for this. So as we did in the beginning, let's duplicate here. And what you typically want to do is you want to also reserve IP pools that you're going to use for your layer 2 or layer 3 services. So think of this as the IP running between the customer equipment and your equipment. So this we might make something like 10.201, and then anything in that /24 or /20 or /22 or whatever will be reserving just for links, because we want to give links IPs in that range. Okay, so 10.201.0.30. So let's make .1 router 6 and .2 the CPE. So I'll go into the Winbox for R6 quickly. I'll add an IP address. My IP address will be 10.201.0.1/30 on the customer VLAN. And for the other side, I'll just quickly jump onto the Winbox or the command line. But it might break. I might have to just quickly redo this. Yeah, it does that. So in the beta, it's not really an issue. It's more of just a annoyance that you need to like backspace some stuff. It works totally fine on Winbox. So actually we might just do that through Winbox, but then I just quickly need to enable ROM-on for this as well. So let's do that. Tool ROM-on set enabled, yes. System identity set name. Let's make the CP10. And if I go into Winbox, I connect to the ROM-on, I should see the CPE come up. So there's the customer equipment, I'm connecting to it. And now from the customer equipment, I'm just going to assign the IP address quickly. And that IP is 10.201.0.2/30, and that's coming in on Ether1. Apply it. So on CPE10, if I do a ping to 10.201.0.1, it's failing, which is interesting to me, but I've got a suspicion it has something to do with this beta version I'm using. So to be honest, I'll just quickly stop this and I'm gonna delete the CPs and just recreate them. Delete the selected. Let's add a new node, 2 new MikroTiks. Select the right version, call it CP again. Router, make it 12 ports, save that. All right, let's reconnect. And we've got connectivity. Let's just start the router up. And let's just see if our neighbor comes back up. Still reading it, but that's just because of the old entry. IP neighbors. Can I refresh this somewhere? It's correct, but that's still the old entry. Just jump in here, see how this looks. Admin blank, no. Okay, that looks good for me. So first things first, we want to add an IP address add. And then our address is 10.201.0.2/30 interface ether1 IP neighbors print. So we're seeing that IP address. Let's see if we can ping it. I'm hoping we can. And now we can ping it. So there was something that the beta version wasn't liking, but it's fine. And that's why also, again, beta is beta stuff. I've seen some people bring the beta versions into their production networks just so that they can run stuff like WireGuard. And it's cool, but you never know what issues you might run into. If it's just WireGuard to a single beta router, that's totally fine. But if you're just changing out your routers like software images with the beta version, you're gonna run into issues. So I highly advise against that. Okay, so now we've got a CPE10, and the CPE10 can actually get onto our network. So we're not really done yet. There's so much more we want to do actually. But let's do something like make router, actually let's delete these, and then I'm going to act as if router 7 will be a BGP peer to the outside, to the intranet, and router 7 will actually be where our intranet links come in and where we get our breakout from. So on our OSPF, even though this isn't what you want to do to provide intranet for your customers, really, for that you most likely want to either create a separate VRF that is specifically for certain customers. So maybe you are a wireless provider, so you might want to just create a VRF for your wireless clients, throw them all into that VRF so that they can't do stuff on your core production network. That's just my suggestion, but we can quickly do a dumb and easy way, and this will now be done with the OSPF. So routing OSPF instance. And then what we could do is we could set, and we could redistribute, or not redistribute, yeah, there, distribute default as, let's always as type 1. So what this command will do is this router 7 will effectively now say, to get a default route, to get to the internet, to get to the anywhere, you can use me, and it will advertise it to all of the other routers. So I'm just going to hit enter, and what I want you to take note of is if I go to like my router 6 now, and if I do an IP route print, and this route wasn't there before, I'm learning the default route through OSPF now. So I could try and ping Google, but I know it's going to fail right now. And the main reason is because router 7 doesn't have a way to break out yet. Hey, Stuart. So let's quickly add another management network. So I'm just going to make another globe, call this intranet. And this will be my management network. Let's maybe change that image for this globe to a PC or something. So it actually looks like that's my management PC there. And then this other one is actually for the intranet. So that I'm going to bring into Ether 3. And then I just quickly need to configure some stuff for intranet onto Ether 3. So let's do that. So I might just do this from the CLI quickly. So biggest thing for me is I firstly just need an IP address. So IP address, add address, and we will be using 192.168.74.100/24 on Ether 3. So this is the IP address on my Eve topology. There's actually like a massive, I don't know, is it a butterfly or bee or something? I don't know. It's crazy. I'm not sure if you guys can hear that. It's very disturbing actually. Sorry about that. So I'm going to do an IP address, or we don't need to do an IP address now. If I do a ping 192.168.74.2, that is actually my NAT adapter to get out to the real internet. So what I could do is I can add a route now, IP route, add, and this is now on router 7. So my destination address would be 0000/0. My gateway will be 192.168.74.2, and I'll hit enter. So if I go back onto my router 6, I wonder if I do a ping to 8.8.8, will it work? No, it's not working, but I kind of have an idea why. And the reason is I'm currently not natting any of my breakout traffic. So let's just quickly do that. Let's do IP firewall NAT, add our source chain, or our chain will be source NAT. Our out-interface will be Ether 3 because it's traffic leaving Ether 3 that we want to NAT out. And our action will be Masquerade. So we will be assuming the IP address of .100 to get breakout. So I'll hit enter. And if I go back to router 6, If I do the ping to Google, it is successful now. So effectively, I've added breakout on my core network towards the internet through, let's say this is an internet link that I've got on router 7. And if I go to my CPE10, let's see, I want to provide the customer some internet now. And again, I would stress putting this in different networks, but just for the now, we'll just leverage this basic internet connectivity that we have. So if I do a ping, if I do an IP route print here, I'm not learning any routes. So this is effectively just like a MikroTik at the customer's premises. Let's just set the identity again. System identity set name equals CPE10. So what I could do is do an IP route add, and then my default gateway or my gateway out would be the IP address between router 6 and CPE10 over this VLAN that we brought in. So my destination address will be this, and my gateway will be 10.201.0.1. I'll hit enter. So if I do a ping out, I should probably get some internet. Let's see. Yes, I do get internet, but this isn't really correct yet because the customer might actually have his own, or she, them, whoever, they might have another, like they would have their own LAN network probably running here. So let's just assume there is actually a LAN network behind the router. So let's add a little desktop, put that behind CPE10, and then we're connecting that on Ether 2. And now our customer tells us, hey, okay, cool. They want to assign, like maybe they don't even tell you, but they want to use 192.168 0.0/24, and .1 will be the router. So let's just quickly assign those details. So let's go back onto the CPE. There's my putty. So on the CPE, we can go IP address, add. The address is 192.168 0.1/24 on Ether 2. Awesome. Wait, I actually don't want to close that yet. And let's just go into this little virtual PC. And on this PC, I'm going to give it the IP address of 192.168.0.2 with 192.168.0.1 being the gateway. It's just checking for some duplicate IPs. And we've gotten access. So let's see, can I ping 192.168.0.1? I can. But from the customer's LAN network, now from their PC, can I get actually internet breakout? No, I'm unable to get any type of internet breakout. And the reason being is on the CPE, I don't have any NAT rule here yet. So my WAN can get over to the internet, but my LAN for the client cannot do that yet. So let's just quickly add that NAT rule. I might do it through Winbox. I just want to enable the ROM-on quickly. So tool ROM-on set enable yes. So ROM-on's enable. So let's quickly check, can I Winbox to this? There's the CPE10. Let's connect. And I'm going to go to my IP neighbors. Well, not my IP neighbors. I actually want to go into my IP firewall. Let's add the NAT rule through here. So it's source NAT. My out interface is Ether 1 because that's where the traffic's leaving. And I can just masquerade that traffic. Let's apply it. Hit OK. And that is perfect. So if I go back onto that little PC, and if I ping out now, hey, I'm getting breakout. That's awesome. So we've now actually provided internet access from a ISP network that we created from scratch in less than an hour, I'd say. maybe an hour and 20 minutes. Let's say an hour and 20 minutes. We've created this ISP network and we've brought a customer online. We're giving them some services, and we could do the same thing for a different customer. I mean, if you were a wireless provider, a WISP like this would be very similar to the setup you might be using, because you'd essentially have your CPEs at the site and you'd NAT the traffic that your core network's seeing for your customers so that they can get breakout that way. So let's just add another MikroTik quickly. Actually, didn't I add another one? No, I didn't. Okay, so let's just add a MikroTik, call this CPE, change the version, make it 12 ports. So we're actually just doing what we already did. I just want to show you that it's going to work for different customers on different VLANs as well. So this new CPE, let's just call it CPE 11 for consistency. And this CPE 11 is also now coming in through that same access switch. And on that access switch, we just need to assign another VLAN. So let's go on to, because it's two different customers, we're not going to use the same VLAN for different clients. We are going to change the VLAN. So I'm going to enable this. I'm going to go into my, let's just do a show VLANs. So I know 1030 is my CPE 10. So let's just add another VLAN for 1031. Give this the name of CPE 11. And what we could do now is go into our interface. And this is E0/2. We're going to set this as switchport mode access, switchport access VLAN. And let's just make that VLAN 1031. Actually, let's change this around. Let's make it a bit more interesting. So let's just make this a switchport trunk, switchport mode, switchport trunk encapsulation.1q, switchport mode trunk, switchport trunk allow VLAN, and then the VLAN we're going to add is the 1031. Int E0/2. I just want to have a look at the running configuration for that E0/2. The mode is correct. Okay, this looks good. So we will just write mem this. Show VLAN. So if I look at the VLANs, it's actually not seeing CPE 11 there, but I haven't tagged it yet on here as well. So let's just quickly bring this up. Oh, hello. So I'm going to go into the admin blanket. Did I hit another key? I wonder. That's just hanging now. Let's just reconnect. Oh, it's giving me the whole license. Okay, system identity set name. Our identity for this was CP11. So what I want to try and do is interface VLAN add, and then our VLAN ID will be the 1031. Our interface is going to be ether1, and our name, we can just call this VLAN to VLAN 10031 to ISP, I guess. Let's hit enter. So if I do an IP neighbor print, I wonder, do I see anything? I'm not learning any MAC addresses. So I feel like there's something on the switch I'm probably missing. Show VLAN. Show run int E0/2. So we've set it for encapsulation.1q, we've set the allowed VLAN. Now why is this being difficult? The int E02. Am I missing something with the switchboard trunk? Allowed VLAN. I've already done this. 1031. E02. I wonder, should I maybe just remove the allowed? Show VLAN. Yeah, let's just remove that quickly. Config T. Interface E02. No switchboard. Trunk. Allow pause. Just want to see if this actually brings this up. So now I'm learning the neighbor. So there's something I'm messing up with. Either this Cisco switch or maybe this virtual image that I'm using isn't working too nicely. But I do have a viral image that I could try and use to replace this with, because the commands seem good to me. It's just if I looked at the VLAN table, it wasn't seeing that the port was being allowed for that. Okay, well, that shouldn't be normal, but it's fine. This is just to show you that we've now assigned a VLAN. Oh, let's go into Winbox for it as well. So tool ROM on set enabled, yes. So if I go into my Winbox, connect to the ROM on, I should see a CPE11. Connect to that. And now from the CPE11, as you can see, we've only got the VLAN for the 1031, and this is actually how we're bringing traffic through now. So let's quickly just add an IP. And like I said, we want to keep the IPs in its same pool for the links. So let's just make this .4. And then what we'll do is we'll make the CPE .6 and the router 6.5. So let's just assign these IPs. So let's go into our CP11, add the IP address, and we'll assign the IP to that VLAN. So 10.201.0.6/30, and that's on the VLAN. And then on R6, do I still have that on here? I do. So we'll just add it through the Winbox as well. So this IP was 10.201.0.5/30 on my VLAN. I've applied it. Wait. That's not the right VLAN. I haven't created the VLAN on the on the core router yet, or on the provider edge. So let's just quickly add it. So I'm going to call this similarly, let's just make it maybe something like 1031 CP11 10 megabits. This was 10.031, and that should be on Ether 3. Let's apply that. So I'm just going to assign that IP address that I put here onto the 1031, the new VLAN. Okay, let's just see, do I actually pick that up in my neighbors? Yes, I do. So I can see 10.201.06. Let's see, can I ping that? I can ping across. That is fantastic. So now I've got 2 customers that I've brought into my little network. I'm going to be making so much money. I've got these customers that's paying me all this money to just you know, use my network to break out to the internet. So let's add another VPC, And this is going to be the curious part, and this is more or less for WISPs now, because you might have these customers use the same IP range, and typically this is where I would tell you, okay, this is where VRF is very useful. But since you're just natting the traffic out that's coming from the customer into your network, you won't need to do that. So we'll use the same IP range just to prove that it works. And I'll start this VPC. And then on the CP11, I'm going to add the address 192.168.0.1/24 on Ether 2. And then on the VPC, let's do an IP 192.168.0.2/24 with 192.168.0.1 being the gateway. And what we want to do now is just quickly add that NAT rule on the CPE, else this will not work. So IP firewall, NAT, source NAT. Our interface is going to be the VLAN now, because that is what's connecting to our core network instead of just the straight interface. And we're masquerading. I'm going to apply this. So if I go into this VPC, which I have here, if I ping 8.8.8.8, destination network unreachable. Why is that? I have an idea why. So 192.168.0.1 is saying I destination network is unreachable. And if I go onto the CPE, let's just do some troubleshooting. If I look at my routing table on the CPE, I don't have any default route yet. So let's just add a default route. My gateway will be the IP address of router 6 on VLAN 10.0.3.1, so 10.2.0.1.0.5. And I can just apply. So now that I've applied that, if I go back to my VPC, let's see if we can actually achieve some breakout now. Yes, we've got breakout. And this is now two separate customers using the same LAN address on their LAN with our CPEs coming into our network through our, we could say it's our wireless network. It could have been a fiber network as well. Maybe like business fiber, where we're not using any type of like triple PoE or anything to bring in or provide that service to the customers. We're just giving them, or we're getting direct layer 2 to our clients, and we're bringing them into our network and giving them internet access now. So that's pretty cool. But again, this is more or less just for if you're going to be natting the traffic out from the CPEs. If you didn't have that and you had both of these 192.168.0.0/24 ranges, this core network wouldn't really know what to do, and one of these customers would be very frustrated. They'd be pretty angry at you because you're not actually giving them a service. They've signed up to you and everything is just bad. They don't have internet connectivity, or when they have it, it's very sporadic. It might even be both customers that's affected because your routes are being shared by the two customers then. But we'll cover more like cooler stuff like that a little bit later. So I'm not going to end off the stream yet. I'm actually enjoying it, even though I'm not getting as many viewers as the last stream. It is quite fun just to mellow out and build a small topology with all of you. While this topology is here, I just quickly want to close this lab, and I want to open up another lab, which is like on a video that I made recently. I didn't make it on this lab, but I'm considering maybe sharing this lab template if there is interest for it. So this template is basically just to, you know, configure VPLS through BGP signaling. And this lab has basically all of the information already, just like on the stream that I just started setting up. There's an mpls network. We've assigned some loopback addresses. There's IP addresses for all of the links, and we're delivering a VPLS service for our customers. So it's pretty interesting stuff. So if there is interest, I might just export the lab and make it available for people to download and play around with and break the lab themselves, you know. something to take note of. But let's get back into our stream lab, because this lab is going to be even cooler than that lab. It's going to exceed expectations. Awesome. So we've got 2 customers. They're pretty happy. They've got internet breakout. I've got a nice little core network going here. My network is running OSPF, and it is running mpls on top of it. So awesome stuff. So what else can we actually try and do on this network quickly? I might bring in one more customer LAN, and then in this customer LAN, let's just add a node, because let's just play around a little bit with BGP, but this will now be BGP in our network. So let's add another router, call this CPE again, set the version, give it more ports, and presto, we've got another CPE. I'm just going to call this CPE 12. Looks a bit weird because now it's going 12, 10, 11, but that's fine. It doesn't matter too much. So this CPE will bring into the switch. And I might just quickly want to run some BGP off of this. So again, let's figure out what IP addresses we want to assign. And this is why it's also so critical for ISPs to have some form of way that they keep track of their IP addresses, like what they're using in their network. So I know a lot of people in the higher tier like to use stuff like info blocks, and that is very useful. But if you don't want to shell out the money for info blocks, then you could potentially also spin up a IPAM server on a Linux distribution, and that would work just fine. It's pretty much free, and you'd be able to keep track of where you're assigning IP addresses. Alright, so let's just assign that IP for this new link. And then what I want to do is start up the CPE. And then guess what? The VLAN, what VLAN will we use? If I'm gonna take a good guess, if I do a show VLAN, I'll just use the next available VLAN. So 1032. So let's go into our config. VLAN 1032. Name. We can call the CP12. And the other thing that I want to do is just give this an access mode. So that will be on E03. So interface E0/3, switchboard mode access, switchboard access VLAN 1032. I'll right mem this. And if I do this show VLAN, I can see this is going to CP12. So I'll cancel that, so I don't need that open anymore. So let's just quickly go into router 6. Assign that VLAN, so that is 10032 CP12. They're a big customer. They've ordered 100 meg link through us. Awesome. 1032 on Ether 3. I'll apply this. And what we can do now is just quickly assign the IP address on router 6. So that IP address is 102.0.9/30. And that's on this new link that we are commissioning now. And if I go to my CPE12, what we want to do is admin blank, no. Let's just set the identity quickly, system identity set name, CPE12, tool ROM-on, set enable, yes. So you'll see this is something that I do by default, is just always make sure I've got an identity set for the router, and also to enable ROM-on, because this tool is so useful. It's really useful, good way to get to your routers if you lose IP communication to the router. ROM1 will still work. Okay, let's add our IP address. Our address is 102.0.10/30. Interface ether 1. Let's quickly see, can I ping across? Yes, so I can get to my provider in the network. And let's quickly add another virtual PC. And this virtual PC will also share the same LAN range as the other customers. But instead of bringing the service in through a static route, I would actually much rather prefer to do this with the BGP, because I love BGP. It's a really nice protocol, and you can run so many different services over it. But lots of uses that you might see for it as an ISP is you might use BGP to configure failover links between customers. So maybe they've got two different links, like a fiber and a wireless link, or two separate fibers through two different providers, but it's coming into your network. Then you could essentially configure BGP on both links going into your network, set different attributes, and then one link would just be preferred over the other link. And then if that primary link should go down, secondary link kicks in, everything works as normal. So BGP is amazing with that. But again, BGP is also the routing protocol of the internet. So if you're peering at an internet exchange, or if you're using some transit network to get internet breakout, you're going to use BGP. Like, that's just how the world works, how the internet works. So let's just duplicate this LAN range quickly. Assign it to the CPE. I think I've still got the Winbox open, or the command line. IP address, add address 192.168.0.1/24 ether 2. And then what I want to do is see, do we have any routes? No, we don't have any routes. So let's just add a nice little shape. Make it again, the square rounded thing is just on EVNG Pro. It's just something to look nice. It doesn't do anything like fancy. Alright, so let's just say this is now my network. This is my core network. This is my ISP network. This is where I'm running my services to give customers services. Let's maybe just duplicate one of these boxes. I just like to state here that this is an MPLS network. Maybe make that a nice B, give it a nice purple, and increase the size a bit. Maybe make it a bit bigger. There we go, that looks quite nice. Make it MPLS. And then one thing that I like to do is let's just duplicate that and give this an AS number. So the AS might be 65000. It's a private AS, I think, I hope. Yeah, so let's just maybe make that a different color just for some niceness. Okay, refresh the topology, and that looks good. So what we want to do now is let's just create another little box, but this box will now be going to that CPE12 where our customer equipment is. And in this little box, we're also going to have a AS, but this will be now an AS that we use to our clients, because we're going to connect to this as eBGP. So I'll make this 100. Cool. So what we want to do is just quickly configure these BGP instances as well as the peers. So we'll just configure the instance on router 6 quickly. And let's just do that on Winbox to show people to do it on Winbox. So we go into our routing, BGP. Let's add a instance. I'll call this AS65000. The AS number will be 65000. And our router ID will be 9.9.9.6, which is that loopback address again. I'm not going to change anything else here. If the customer had their own VRF, well, no, this wouldn't even be at the customer's VRF now. This is just for my core network. So let's apply this. And then my peer, I can quickly add, and this peer will just be peer to CPE12. We'll select the instance as 65000. Our remote address will now be the actual IP address of the link, so 10.201.0.10. 10.201.0.10. And our remote AS, we've specified it will be AS100, so let's use that. We're not multi-hopping and we're not route reflecting. And we can use BFD. BFD is very nice protocol that will just make your convergence time quicker. So if the link drops and you had another BGP peer, it would instantaneously pick up the links down and make things better. So let's just check advanced. We can set the update source as the VLAN going to CPE12, and we're just going to leave the address family as IP. We're not going to do any of these fancy things yet. So let's apply this. And if I go onto the CPE12, this I might just quickly do from the command line. So on CPE12, all that we want to do is we want to say, hey, we're going into the routing, we're going into the BGP, we're adding an instance. So we're going to add, our name is going to be AS100. It could be data or voice or whatever you want to make it, but I'm just going to call it AS100. Our AS will be 100. And our router ID in this instance, and this is also why it's wise to have unique link addresses, will now be the link address of 10.201.0.10. And I can just hit enter. And then I want to add a routing BGP peer, add, and then our remote AS is 65000. Our remote address is going to be 10.201.0.9, which is the IP address of the link at router 6. We can give this a name as primary underscore data. And let's see, is there anything else we want to add here? So we've got a AS, we've got a address, we've got a name. Oh, and we need to set the instance as the AS100. That's pretty important. Oh, and we are using the BFD. So BFD is being used. We can set the update source as well. And that update source should be Ether1. We didn't configure VLAN on the CPE. Perfect. So if I go now and look at my routing, BGP peer, print status, it is established. And this is going to router 6 now. So at router 6, there's actually one more thing that I want to do from Winbox. And that is on this peer. I just want to go to the general. And then if I go down, there's a default originate. So what I want you to take note of is with default originate, that's basically like telling your peer if you're going to send out a default route to them. So make sure you're never default originating from a CPE to your own network, because you might be injecting a default route from a customer to your network and you can cause yourself a lot of havoc. So in this case, we're just doing a default originate to router 6, but before I enable it, I just want to, or not router 6, CPE 12. So on here, I just want to do IP route print. No shenanigans. We're just seeing our directly connected routes. So you would be dropping attributes by using route filters. If that's what your goal is, you would be either, if it is a downstream peer, then that would be an out filter, and if it's an upstream, or if it's like a link coming into you, that would just be an in filter, and that's where you can adjust some of the attributes. I can quickly show you as well, just as soon as I redistribute this default route. So we can say this is always apply, okay. So if I go back onto my CPE 12, I'm actually learning a default route now. So if I do a IP firewall NAT add chain is source, out interface will be ether 1, and our action will be Masquerade. This last VPC for this other customer will also now have internet access out. So let's just do an IP 192.168.02/24 with 192.168.0.1 being my gateway. And let's see, can I ping out? Amazing. I've got 3 customers now. I'm soon to stop working and making YouTube videos and just rolling in the money. Anyways, so now we've got a BGP peer configured to CPE 12 to distribute a default route to it. And you see we're not actually doing any of the other cool stuff that you'd actually use BGP for. This is just a very basic use of it to send out a default route to a remote peer. So your question was about the BGP attributes. So I'm just quickly going to go into Winbox, and then I want to show you at your peers. So if this peer to CPE 12, if this wasn't a like a CPE, if this was like an upstream of mine and they are a transit network and I'm peering with them to learn all of my internet links and stuff, if I wanted to change anything with the BGP attributes, firstly you would use the route filters. So since they are sending the routes to me, I would be using an in filter. And then from the in filter, if you go into your routing BGP, or not BGP, you just go to the filters. Here you can change anything that you want with the BGP. And you can also change some of the attributes. So here is, with the BGP actions, you can actually change some of the attributes. I think you also asked some questions last time about the communities, and this is also where communities would come into play. So it has a lot to do with the filters. I don't think I'm going to be going over the filters tonight. I have made a video before about BGP filters, but not in depth about like communities and stuff. But I will see if we could maybe in a continuation stream play around with some of the communities. But again, with the route filters, this is where you'll come to change some of the BGP actions. I could probably just show you on the customer CPE how we can manipulate some of that. So luckily I've got Winbox or Romon enabled to CPE 12. All right, so let's go on to CPE 12, and then on CPE 12, on the routing, on the filters. So first I want you to see, if I go into my IP routes, and if I double click on this BGP route I'm learning, I can actually see like the attributes. There is my BGP AS path. I can see this shows it is an IGP, but this is actually EGP. Since I've peered with a external autonomous system number. Yeah, I hear you. So we can definitely make something about that, I think. Maybe I'll do a video tutorial on the communities as well, just so it's a bit more in depth. Let's just do something very basic with the route filters quickly. So with the filters, what I could do is I could add a chain. So the chain, just think of this as a name for your route filter. So I might call this primary. And I'm not going to adjust any of the prefixes here. The prefix, this is where you could set to maybe either drop or accept or something based on the prefix. But I'll just say anything primary on that BGP peer. So what I want to do is we will accept, and now I can change some of the values. So if I made the med like 1000, and if I had another BGP peer and that med was 2000, this BGP peer would be preferred. Other things I could do is maybe just change the distance. So instead of the default 20 that it is now, if I apply, and if I apply this filter to my peer on my in, because this is routes that I'm learning that's coming into my network from the CPE. If I apply that, you see my distance has already changed. And if I look at my attributes, I can see I've added a med there. Currently, I'm not like doing anything with the communities, but again, all the community stuff, this has to do with filters. So it can get a bit, I don't want to say hectic, but you need to know what's happening with the route filters as well. Alrighty. Wow, it's almost been 2 hours that I've been streaming. Fantastic. So guys, I am actually going to end off the stream here. I've actually had a blast, and I'm definitely going to keep the lab as is and then build off of this in the next stream, which will be next week Tuesday at 8 p.m. UCT or UTC or whatever +2. And then we can revisit a few more things, but we've made a lot of headway in these 2 hours. We've created a core network, we've given some customers internet services, and it's been a blast. So thanks so much for watching, and I'll catch you guys in the next stream or in the next tutorial video. So see ya.